Hey friends, welcome to the YouTube channel all about electronics. So in this video, we will see that how to analyze the sequential circuits or the finite state machine using the state transition diagram. So basically, we will see that if we have been given a sequential circuit, then how to draw its state transition diagram. So if you have followed the previous videos, then we understood that the FSM or the finite state machine is an abstract model to represent the sequential circuits. And often these sequential circuits are also referred as the finite state machine. And then we have seen the two FSM models, that is Mealy machine and the Moore machine. So now let us see if we have been given any sequential circuit, then how to analyze it. So we can analyze the behavior of any sequential circuit using the state transition diagram and the state table. So first, let us see if we have been given any sequential logic circuit, then how to draw its state diagram. So in the previous video, we have already seen some basics of the state diagram. And we have seen that the state diagram is a pictorial way of representing the behavior of the FSM. So in the state diagram, the each state of the circuit is represented with the circle, and the transition from the one state to the other state is represented with the arrow, and the value on the top of the arrow represents the input which will lead to this state transition. Now in the state diagram, in the given state, for each input value we can have only one possible transition. That means in a given state, for a given input value we cannot have more than one possible transitions. For example, if the circle is in 0 state and if the input is equal to 0, then it will remain in the same state. But at the same time, for the same input, it cannot have another possible transition. That means for the each input, it has only one possible transition. Apart from that, each state in the state diagram must specify what happens for the each possible input combination. For example, in the circuit, if we have only one input, then in the each state, we have only two possible outgoing transitions. That is whenever the input is equal to 0 and when input is equal to 1. But both the possible input combinations should be specified in the state diagram. For example, if you see this state diagram, then here in the each state, it has been specified that what happens when the input is equal to 0 and the 1. But suppose if it is not specified, for example, if this transition or this transition is not specified, then the given state diagram is the invalid. Because in this diagram, when the input is equal to 1 in the 1 state, then it is not specified that what happens next. That means in the each state, all the possible input combinations and the relevant transitions should be specified. And if the state diagram is of the Mealy machine, then the value next to the input represents the output corresponding to the given input. And we have seen that in case of the state diagram of the Moore machine, the output is represented within the circle itself. Because in the Moore machines, the output is the function of only the present state of the memory elements. So in the previous video, we have seen some basic information about the state transition diagram. So now, let us see if we have been given any sequential logic circuit, then how to draw its state diagram. So first, let us see the state diagram of very basic memory elements using which we are building these sequential circuits. So first, let us see the state diagram of the flip-flops. And let us see how to represent the behavior of the flip-flops using the state transition diagram. So first, we will start with the D flip-flop. So in the earlier videos of the D flip-flop, we have already seen its state table. So if the input of the D flip-flop is 0, then its output will also be equal to 0. And at the clock edge, when the input is equal to 1, then its output is also equal to 1. So this is the state table of the D flip-flop. So in the flip-flop, we have only two possible output states. Let's say that is equal to S0 and the S1. So this S0 is a state when its output is equal to 0, while the S1 is the state when its output is equal to 1. So currently, if the output of the flip-flop is 0 and if the D input is equal to 0, then it will remain in the same state. And therefore, its output will also remain 0. On the other hand, in the same state, if the input is equal to 1, then the output will also become 1 and it will do a transition from S0 to S1 state. Similarly, if the output of the flip-flop is 1 Or if the flip-flop is in S1 state and if we apply a 0 as an input, then its output will also become 0 and it will do a transition from S1 to S0 state. On the other hand, in the same state, if the applied input is equal to 1, then the flip-flop will remain in the same state and its output will also remain 1. So as you can see, in the each state, we have only two outgoing transitions. So one is when the input is equal to 0 and the other one is when the input is equal to 1. So this is the state diagram of the D flip-flop. So similarly, let us see the state transition diagram of the T flip-flop. So this is the state table of the T flip-flop. And as we have seen the earlier video, in the T flip-flop, when the input is equal to 0, then the output of the flip-flop will remain in the same state. And whenever the input is equal to 1, then the output of the flip-flop will toggle. That means currently, if the output of the flip-flop is 0 and if we apply 1 as an input, then the output of the flip-flop will toggle from the 0 to 1. Likewise, if the t is equal to 1 and the present state of the flip-flop is 1, then it will toggle from 1 to 0. So using the state table, we can easily draw the state diagram. So once again, the flip-flop has only two possible output states, that is S0 and the S1. So this S0 is a state when the output of the flip-flop is 0 and the S1 is the state when the output of the flip-flop is 1. So in this S0 state, if the input of the flip-flop is 0, then it will remain in the same state. That is this condition. That means in this condition, the output of the flip-flop will also remain 0. Similarly, when the flip-flop is in S1 state and if the input is equal to 0, then it will also remain in the same state. And in that case, its output will also remain 1. But when the input is equal to 1, then there will be a state transition and the output of the flip-flop will toggle. That means if the flip-flop is in S0 state and if the input is equal to 1, then there will be a state transition from S0 to S1 and the output of the flip-flop will also toggle from 0 to 1. Likewise, if the flip-flop is in S1 state and if the input is equal to 1, then it will go from S1 to S0 state and in that case, its output will also become 0. So this is the state transition diagram of the T flip-flop. So similarly, now let us see the state transition diagram of the JK flip-flop. So this is the state table of the JK flip-flop. So as we know, in the JK flip-flop, we have two inputs, that is J and K. So depending on the value of the J and K inputs and the present state of the flip-flop, we will get the specific output at the next state. So once again, the flip-flop will have two possible output states, that is S0 and the S1. So this S0 is a state when the output of the flip-flop is 0 and this S1 is the state when the output of the flip-flop is 1. So currently, let's say the flip-flop is in S0 state. So in this state, if both J and K inputs are 0, then the flip-flop will remain in the same state. So here, the first input value represents the J input, but the second value represents the K input. Similarly, when the J is 0 and K is 1, then also the flip-flop will remain in the same state. So in general, we can say that when J is 0 and K is equal to X, then the output of the flip-flop will remain 0, or in other words, the flip-flop will remain in the S0 state. Likewise, currently if the flip-flop is in S1 state, and if the J and K inputs are 0, then the flip-flop will remain in the same state, and therefore its output will also remain 1. Similarly, in the S1 state, if J is 1 and K is 0, then also the flip-flop will remain in the same state. So in general, we can say that when the J is equal to X and the K is equal to 0, then the flip-flop will remain in the S1 state and its output will remain 1. Likewise, currently if the flip-flop is in S0 state and if the J and K inputs are 1 0 or 1 1, then it will go to the S1 state. Because as you know, when J is 1 and K is 0, then the output of the flip-flop will become 1. Likewise, when both J and K inputs are 1, then the output of the flip-flop will toggle. That means in both these conditions, the flip-flop will transition from S0 to S1 state. Or in general, we can say that when J and K inputs are 1 and X, then the flip-flop will do a transition from S0 to S1 state. And in that case, the output of the flip-flop will change from 0 to 1. Likewise, if the flip-flop is in S1 state and if J and K inputs are 0 1 or 1 1, then it will do a transition from S1 to S0 state, and in that case the output of the flip-flop will become 0. So as you know, when the J is 0 and K is 1, then the output of the flip-flop will become 0. And likewise, when both J and K inputs are 1, then the output of the flip-flop will toggle. Therefore, it will do a transition from S1 to S0 state. So in general, we can say that when this J is equal to X and K is equal to 1, then the output of the flip-flop will change from 1 to 0. So this is the state transition diagram of the JK flip-flop. So in this way, we can draw a state transition diagram of the flip-flops. So now, let us see how to draw a state transition diagram of the sequential logic circuits, which is made up of these flip-flops and the other logic gates. So let's say we want to find the state diagram of the given logic circuit. So first of all, we need to find out whether this sequential circuit is of Mealy type or the Moore type. So here, as you can see, this X and Y are the inputs and this Q is the output. So as you can see in this circuit, here the output Q only depends on the present state of the D flip-flop, and it does not depend on the inputs X and Y directly. So we can say that the given circuit is the Moore machine, and therefore here in the state transition diagram we will represent the output in the circle itself. So here, since we have only one flip-flop, so the circuit will have only two states. Let's say that is equal to S0 and the S1. So here the output of the flip-flop is the output of the circuit. That means whenever the circuit is in S0 state, then its output will be 0, and whenever the circuit is in the S1 state, then its output will be equal to 1. So now, to find the state transition diagram, first of all let us write the state equations of the circuit. And from the state equations, we can easily draw the state diagram. So here if you see, then this D input is equal to X XOR Y dot Qn whole bar. That means here, this input is equal to X XOR Y. And the second input to the NAND gate is equal to Qn. That is the present input of the D flip-flop. Therefore, the output of this NAND gate is equal to X XOR Y dot Qn whole bar, where this Qn is the present state of the D flip-flop. And as you know, for the D flip-flop, the output is the same as the D input. That means in the next state, the output of the D flip-flop will be same as the D input. That means we can say that this Qn plus 1 is equal to D. So using the state equations, we can easily draw the state diagram. So as per this equation, when the circuit is in S0 state, then this Qn output will be equal to 0. And as you know, when any one of the input of the NAND gate is 0, then its output will be equal to 1. That means whenever this Qn is equal to 0, or whenever the circuit is in S0 state, then the input to the D flip-flop will be equal to 1. And as you know, for the D flip-flop, when its input is equal to 1, then its output will also be equal to 1. So we can say that when the circuit is in S0 state, then irrespective of the value of the X and Y, at the next clock age, the circuit will go into the S1 state, and therefore its output will become 1. Similarly, let us see what happens when the circuit is in S1 state, or in other words, when the Qn is equal to 1. So when the circuit is in S1 state, then this Qn will be equal to 1. That means in that case, this D input is equal to X XOR Y whole bar. So now, if both the inputs X and Y are different, in that case, this X XOR Y will be equal to 1. And in that case, this D input will be equal to 0. That means whenever this X is 0 and Y is 1, or X is 1 and Y is 0, in that case, this X XOR Y will be equal to 1. And therefore, this X XOR Y whole bar will be equal to 0. So in that case, the input to the D flip-flop will be equal to 0, and therefore at the next clock age, its output will also become 0. Therefore, the circuit will do a transition from S1 to S0 state, and its output will also become 0. Similarly, in the same state, when both X and Y are equal, that means either 0 0 or 1 1, in that case, this D input will become 1. Because here, this Qn is already equal to 1. So in that case, the circuit will remain in the same state and its output will also remain 1. So in this way, with the help of the state equations, we can easily draw a state transition diagram. And this is the state transition diagram of the given circuit. So similarly, let us take another example and let us find out the state diagram of the given circuit. So first of all, let us find out whether the given circuit is a Mealy type or the Moore type. So if you see over here, then it is a Moore machine. Because here, this output Y only depends on the present states of these two flip-flops. That means the given sequential logic circuit is a Moore machine. And therefore in the state diagram, we will represent the output within the circle itself. So in this circuit, as you can see, we have a one input X, one input Y, and we have two flip-flops. That means the number of states of the circuit is equal to 4. So now, before drawing a state diagram, first let us find the state equations of the given circuit. And with the help of the state equations, we can easily draw a state diagram. So here, these T1 and T2 are the inputs to the T flip-flops. And the output of these two flip-flops are A and B. So here, as you can see, this T1 is equal to X dot Bn, where the Bn is the present state of this second flip-flop. And likewise, this input T2 is equal to X. And if we see the overall output Y, then this Y is equal to A dot B. So using the state equations, we can easily draw a state transition diagram of the given circuit. So like I said, since the circuit has a two flip-flops, so there will be a total 4 states in the given circuit. So here, the 4 states are represented in the circle. So here, this first bit in the circle represents this output A, while the second bit represents the B output. And since it is a Moore machine, so the output is shown within the circle itself. So here, as you can see, this output Y is equal to A dot B. That means here, this output will be 1 when both A and B inputs are 1. And otherwise, its output will be equal to 0. That means here, the output is equal to 1 only in this 1-1 state. So initially, let's say the circuit is in 0-0 state. That means here, both A and B inputs are 0-0. And let's assume that initially, this X is equal to 0. So in that case, from these two equations if you see, then this T1 will be equal to 0, while the T2 will also be equal to 0. That means at the next clock edge, these two flip-flops will remain in the same condition. That means whenever the input X is equal to 0, then the circuit will remain in the same state and its output will also remain 0. Similarly, in the same state, let us see what happens when the input X is equal to 1. So as per these two equations, this T1 will remain 0. Because as you can see, currently this B output is equal to 0. Therefore, this T1 will remain 0. On the other hand, since the input X is equal to 1, so this T2 will become 1. That means for the next clock edge, this input T1 is equal to 0, while the input T2 is equal to 1. Therefore, the first flip-flop will remain in the same state, but the second flip-flop will toggle. That means in the next state, this output A will remain 0, while this output B will become 1. Or in other words, we can say that the circuit will toggle from the 0-0 to 0-1 state. And it will happen when the input X is equal to 1. And once again, since the output Y is equal to A dot B, so its output will remain 0. So similarly, now let us see what happens when the circuit is in 0-1 state. So when the circuit is in 0-1 state, then this A output will be equal to 0, while the B output will be equal to 1. And first let us see when this input X is also equal to 0. So as per these two equations, when the input X is equal to 0, then this T1 and T2 will remain 0. And in that case, the output of these two flip-flops will not change. That means whenever this X is equal to 0, then the circuit will remain in the same state. But now let us see what happens when this input X is equal to 1. So in that case, as you can see, this first input T1 will become 1. Because here, this B is 1 and this X is also equal to 1. And likewise, the second input will also be equal to 1. That means now if you see that the input to the both flip-flops are 1 and therefore both the flip-flops will toggle. That means now the output of the first flip-flop will become 1, while the output of the second flip-flop will become 0. Or in other words, if you see, then the state of the circuit will change from the 0 1 to 1 0. And it will happen when this x input is equal to 1. So similarly, now let us see what happens when the circuit is in 1 0 states and the input is equal to 0. So when the circuit is in 1 0 state, then this output A is equal to 1, while this output B is equal to 0. And let's see what happens when the input x is equal to 0. So once again, when the input x is equal to 0, then both the T1 and T2 will be equal to 0. And therefore, the output of these two flip-flops will not change. That means whenever the input x is equal to 0, then the circuit will remain in the same state. But now let us see what happens when the input x is equal to 1. So whenever the input x is equal to 1, then this T2 will become 1. But in this case, this T1 will remain 0. Because here, this B output is equal to 0. That means now for the next clock edge if you see, then this T1 is equal to 0, while the T2 is equal to 1. Therefore, the first flip-flop will remain in the same state, while the second flip-flop will toggle. That means now at the next clock edge, the output of the first flip-flop will remain 1, while the output of the second flip-flop will toggle from 0 to 1. And now, both the outputs will become 1. That means now, both A and B outputs will become 1 1. And the same transition can be shown like this. So in this way, we have also seen the two possible output transitions for this 1 0 state. So similarly, now let us also see the two possible output transitions for this 1 1 state. So let's say currently the circuit is in the 1 1 state. That means this A and B outputs is equal to 1. And initially let us assume that this input x is equal to 0. So as you can see from the state equations, when the input x is equal to 0, then this T1 and T2 outputs will remain 0. And as you know for the T flip-flops, when the input is 0, then this T flip-flop will remain in the same state. That means at the next clock edge also, the output of these two flip-flops will remain same. And since A and B is equal to 1, so the output of the flip-flop will also remain 1. But now let us see what happens when the input x is equal to 1. So when the input x is equal to 1, then this T1 will become 1, but the T2 will also become 1. Because here, this B is equal to 1, but the x is also equal to 1. So now, since both T1 and T2 are 1, so the output of these two flip-flops will toggle. That means at the next clock edge, this A will become 0, while this B will also become 0. And therefore, the circuit will do a transition from 1 1 to 0 0. And it will happen when the input x is equal to 1. So now, since both A and B are 0, so the output of the overall circuit will also become 0. So in this way, we have drawn the state diagram of the given circuit. So if you observe over here, then this circuit acts as a counter. That means whenever the input x is equal to 1, then it will count in the upward direction. And whenever this input is 0, then it will remain in the same state. So in this way, by looking at the state diagram, we can find the behavior of the given sequential circuit. Now so far, both the sequential logic circuits which you have seen were the Moore machines. But similarly, now let us also take one example of the Mealy machine. So now, let us find the state diagram of this given sequential circuit. So first of all, we need to identify that whether the given circuit is a Mealy machine or the Moore machine. So in this case, if you observe, then the output of the circuit depends on the present state of the flip-flop as well as the present input. That means the given circuit is a Mealy machine. And therefore in the state diagram, we will represent the output just next to the input. So if you observe over here, then we have a one input, one output and the two flip-flops. That means the circuit will have total 4 states. So now, before finding the state diagram, first of all let us find out the state equations of the given circuit. And with the help of it, we will easily draw the state diagram. So here, if you see this D1 input, then this D1 is equal to x bar dot q2 plus x dot q1 dot q2. That means here, the one input to the OR gate is equal to x bar dot q2, and the second input to the OR gate is equal to x dot this q1 dot q2 bar. On the other end, the input to the second D flip-flop is equal to X. So as you know, for the D flip-flop, in the next state, the output is same as the input. That means here, this Q1 plus and the Q2 plus will be equal to D1 and D2. Where here, this plus indicates the next state of the flip-flops. And here as you can see, this output Y is equal to X bar dot Q1 dot Q2. So with the help of the state equations, we can easily draw the state diagram. So first, since the sequential circuit has a 2 flip-flops, so it will have total 4 states. So here, these 4 states are represented with the 2 bits, where the first bit represents the D1, while the second bit represents the D2. So initially, let us assume that the circuit is in a 0-0 state. That means here, both Q1 and Q2 is equal to 0-0. So now let us see what happens when the input X is equal to 0. So as per these equations, when the input X is equal to 0, then this D1 will be 0, while the D2 will also be equal to 0. And since both D1 and D2 are 0, so in the next state, the circuit will remain in the same state. And here, based on the present inputs Q1 and Q2, this output Y will also remain 0. So we can say that when the circuit is in 0-0 state, and when the input X is equal to 0, then the circuit will remain in the same state. So in the same state, now let us see what happens when the input X is equal to 1. So when the input X is equal to 1, then once again, this D1 will remain 0. Because here, both Q1 and Q2 are 0. But now, this D2 will become 1. That means now for the next state, this D1 is 0, but the D2 will become 1. And therefore in the next state, this Q1 will remain 0, but the Q2 will become 1. That means now, at the next clock edge, the circuit will do a transition from 0-0 to 0-1. And based on the current inputs Q1 and Q2 if you see, then still, this output Y will remain 0. So we can say that when the circuit is in 0-0 state, and when the input X is equal to 1, then the circuit will do a transition from 0-0 to 0-1. And in that case, its output Y will remain 0. So here, while calculating this output Y, we are considering the present states of the 2 flip-flops. So similarly, now let us see when the circuit is in a 0-1 state. That means whenever the Q1 is 0 and the Q2 is equal to 1. And first let us see when the input X is equal to 0. So when the input X is equal to 0, then first of all, this D2 input will become 0. While if you see this D1 input, then D1 input will become 1. Because here, this X bar will be equal to 1, but the Q2 is also equal to 1. Therefore, this D1 input will become 1. So now if you see, then for the next clock edge, this D1 is 1, but the D2 is equal to 0. That means now, at the next clock edge, this Q1 will become 1, while the Q2 will become 0. And therefore, the circuit will do a transition from 0-1 to 1-0. On the other end, based on the current inputs Q1 and Q2 if you see, then this output Y will remain 0. Because presently, this Q1 is 0, while the Q2 is equal to 1. That means the output of this AND gate will remain 0. So in the state diagram, we can say that when the input is equal to 0, then the circuit will do a transition from 0-1 to 1-0 state. And in that case, its output Y will remain 0. So similarly, in the same state, now let us see what happens when the input X is equal to 1. So in that case, if you see, then this D2 input will become 1, but this D1 will remain 0. Because in this case, since the X is equal to 1, so this X bar will become 0. And over here, this X is 1, but this Q1 is 0 and the Q2 is equal to 1. Therefore, this term will also become 0. That means whenever the X is equal to 1, then the D1 will remain 0, while the D2 will become 1. And therefore at the next clock edge, this Q1 will become 0, while the Q2 will become 1. That means in this condition, the circuit will remain in the same state. And in that case if you see, then based on the current inputs Q1 and Q2, this output Y will remain 0. So the same thing is shown over here. So in this way, we have covered the two possible output transitions for this 0-1 state. Similarly, now let us see what happens when the circuit is in 1-0 state and the input x is equal to 0. So once again, when the input x is equal to 0, then based on these equations, this D2 input will remain 0. And similarly, this D1 input will also remain 0. Because here, since x is equal to 0, so this x bar is equal to 1. Moreover, here this Q2 is equal to 0, while the Q1 is equal to 1. That means here, we will have 0 dot 1 dot 1. So as you can see, both the terms will be equal to 0. That means here, both D1 and D2 inputs is equal to 0. That means at the next clock edge, both these outputs Q1 and Q2 will become 0. And therefore, at the next clock edge, the circuit will do a transition from 1 0 to 0 0. And in this condition, if you see, then this output Y will remain 0. Because here, this Q2 is equal to 0. So we can say that in this transition, the output Y is equal to 0. So now in the same state, let's see what happens when the input X is equal to 1. So whenever this input X is equal to 1, then first of all, this D2 input will become 1. And over here if you see, then we will have this 0 dot 0 plus 1 dot 1 dot 1. Because here, since the Q2 is equal to 0, so this Q2 bar will become 1. That means whenever the circuit is in 1 0 state, or in other words, when the Q1 and Q2 is equal to 1 0 and the input X is equal to 1, then this D2 input will be equal to 1, or the D1 input will also be equal to 1. And therefore, at the next clock edge, both the Q1 and Q2 outputs will become 1. That means at the next clock edge, the circuit will do a transition from 1 0 to 1 1. And in that case, if you see, then based on the current inputs Q1 and Q2, this output Y will still remain 0. Because in the present state, this Q1 is 1 while the Q2 is equal to 0. Therefore, the output of this AND gate will remain 0. So the same transition is shown over here. So similarly, now let us see when the circuit is in the 1 1 state. So in that case, both Q1 and Q2 will be equal to 1. And first, let us analyze the circuit when the input X is equal to 0. So when the input X is equal to 0, then first of all, this D2 input will become 0. On the other hand, if you see this D1 input, then it will become 1. Because here, since the X is equal to 0, so this X bar will be equal to 1. And this Q2 output is also equal to 1. Therefore, this D1 input will become 1. So now, this D1 input is 1, while the D2 input is equal to 0. That means at the next clock edge, this Q1 will remain 1, while the Q2 will become 0. And therefore, the circuit will do a transition from 1 1 to 1 0. But in this condition, if you see the output Y, then based on the present inputs Q1 and Q2, it will become 1. Because here, currently, both Q1 and Q2 is equal to 1, while the X is equal to 0. Therefore, this X bar will become 1. And in this condition, if you see, then this output Y will become 1. So the same transition is shown over here. So similarly, now let us see the last condition when the circuit is in the 1 1 state and the input X is equal to 1. So now, this Q1 and Q2 outputs are 1 1 and the input X is also equal to 1. So since the input X is equal to 1, so this D2 input will become 1. But now, this D1 input will become 0. Because since the X is equal to 1, so this X bar will become 0. Therefore, this term will become 0. And over here, since both Q1 and Q2 is equal to 1, so here we will have 1 dot 1 dot 0 and that is equal to 0. That means whenever the input X is equal to 1, then this D1 is equal to 0 and the D2 is equal to 1. Therefore, at the next clock edge, this Q1 and Q2 will become 0 1. That means now the circuit will do a transition from 1 1 to 0 1. And here, since the X is equal to 1, so this X bar will become 0. That means in this condition, the output Y will remain 0. So in this way, we have covered all the possible output transitions for the each state. And this is the state diagram of the given circuit. So basically, this circuit is a sequence detector and it is finding a 1 0 1 0 sequence. So if you see over here, Then when the circuit finds the correct digit of the sequence, then it moves from the one state to the other state. And the output of the circuit becomes 1 when the input sequence is equal to 1 0 1 0. That is 1 0 1 0. So then and then only the output of the circuit will become 1. So in this way, with the help of the state diagram, we can analyze any sequential circuit. So now in the next video we will see that if you want to design such circuits, then what steps that we need to follow. But I hope in this video you understood how to analyze any sequential circuit with the help of the state diagram. And if you have been given any sequential circuit, then how to draw its state diagram. So if you have any question or suggestions, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.